This video will derive the third kinematic equation. So in our previous two problems about Dr. Perry, we were able to find the final velocity in the first problem and then the displacement in the second problem. Now, in the second problem, there was actually an intermediate step of we found the final velocity and then used the final velocity from problem 1 to solve for the displacement in problem number 2. What if instead we just wanted to be able to have one equation to solve for the displacement given the initial velocity, the time, and the acceleration? To do this, what we can use is equation number 1 and equation number 2 in combination to eliminate the final velocity and have an equation that solves for displacement given these three variables. So let's take our two previous equations. Our first equation, v final equals v initial plus at, and our second equation that told us that our displacement was equal to 1/2 v initial plus v final times t. So we're trying to eliminate the final velocity and we want to solve for the displacement, so it makes sense to take this value for the final velocity and plug it into this equation and then simplify. So if we do that, we get x equals 1/2 v initial plus v initial plus at all times t. Now we just need to do a little bit of simplifying. If we take this equation, v initial plus v initial is just 2 times v initial plus at all times t. And then I want to multiply out the 1/2 and the t. So 1/2 times 2 vi times t is just vi t plus 1/2 at times t, or 1/2 at squared. So our final third equation becomes x equals v initial t plus 1/2 at squared. And you may have seen a form of this in your Algebra 2 class, but it's a common thing to be graphed and be able to look at a quadratic relationship. And this is the third equation. And now, if you go to the next video, you can find the derivation for the fourth equation.